Hello viewers, you are welcome to this video lecture. I am here to present the 18th video lecture from chapter 5. Chapter 5 deals about the Earthwork quantity and mass flow diagram. In the previous videos we will be deals about generally about the Earthwork activities. It is from the clearance up to the finishing course. Also will deals in earthworks and also two type of earth end area calculation parts, the plane meters, or also by using the electronic programs, and also will be deals about calculating earthwork volumes. So this will be by using average end methods, by using area 1 plus area 2 over 2 times the length between the two adjacent areas. Also will be deals, and also will be deals about the shrinkage and swelling factors. Shrinkage factors will be related to the fill parts, and also will be the cutting parts will be related to the swelling parts. So this will be deals in the previous video. Now will be to present the mass flow diagrams, and also will be balancing earthwork using the mass flow diagrams. Also will be deals. In mass flow diagrams is a curve in which the x-axis is represents the stations of the survey, and ordinates or y-axis is represent the cumulative or algebraic sum of the cutting and filling quantity of a volume. The plot can be any scale depending upon the quantities involved, and also the mass flow diagrams designed by programs, computer programs, by inputting the horizontal alignment, vertical alignment, and as well as the cross sections. Mass flow diagrams also a continuous curve shows the cumulative algebraic sum of the cutting. Mostly the cutting volume is positive, and the filling volume will be a negative from the initial up to the ending stations. And also it is convenient to table the cumulative number of cutting and fills at stations before drawing a mass flow diagrams. And also will be more currently highway design computer programs will be provide of the mass flow diagrams by inputting the typical section or the cross sections, and also will be the horizontal and the vertical alignments as inputs. So there is a high amount of or minimum amount of earthwork will be adjusted by using the alignments. General steps followed by determine the mass flow diagram is first will be calculate the fill and cutting areas separately, and we have coming to calculating the area, calculating the fill, and current volume is calculated from the volume by using area 1 plus area 2 over 2 times the length, and we have there is swelling and shrinkage factors will be correct the volumes. The swelling factors will be related to the cutting volume, and the shrinkage will be related to the filling. And table the corrected cutting and filling volume, and aggregate the volumes in the following formats. Is the first column is a station, so the stations will be listed below, and individual volume. So there is a given volume, it is we have proceed. If there is area, so we have calculating a volume. So the volume is a positive value, it is a cutting, and the negative value is a filling. So there is a shrinkage and swelling factors will be placing this. For example, the fill is 100 meter cube, so the shrinkage factor will be 10%. So 100 times 10% plus 100, so 100 times 10% will be 10 plus 100, there is 110 meter cube is required for the filling. After there is correcting individual volumes, so we have coming to the aggregate. The aggregate is we have add the preceding the volumes, cutting as well as filling in one aggregate volume. To plot mass hole diagrams, the x coordinate will be stations, the distance, and the aggregated volume will be placing in one y coordinates, and also will be the mass hole diagrams can be used to determine the first is proper distribution of excavation material. So when there is amount of cutters, so this material is suitable for the borrow material will be the cutting material will be fill the fill sections. So this is first is proper distribution of the excavated material, and the other one is the amount and the location of the waste material. So there is a waste material, there is not suitable for the construction purpose, so this will be removed from the site. And amount and the location of borrow material, so there is the material is suitable for construction or embankment of sub-base or base material will be uses. So how much amount and location will be borrow material will be determined by mass hole diagram. And also the amount of overhead distance, there is above the freehill distance there will be overhill distance. So the overhill distance each kilometer will be paid with cubic meters. And also will be deals about the directions of hills also will be determined by mass hole diagram. So in the following figures will be say the mass hole diagrams also and also the profile. So the double lines will be in the profile lines will be it is a cutting section or excavation, and the arrow direction of hailing will be this one is in this direction and this direction. So this material is suitable, so we have fill the earth. And also the mass hole diagrams, the material moves from the rising lines to the filling lines. So this one is the first is the profile. The profile is will be drawn by using the x-axis by station, and y-axis will be the volume, not aggregated volume. It is cutting or directly we use is a filling section. This one is cutting filling section. This one is a cutting section, filling section, cutting section. But in mass hole diagrams, the y-axis will be changing into the aggregated volume. So the aggregated volume in this section is a cut section, this one fill section, this one is a cutting section. So the difference between the mass hole diagram and the profile is the volume is directly for the profile. For mass hole diagrams, the volume used is the aggregated. Note that the properties of mass hole diagram as follow. As the figure, the upward slopes on the mass curves indicates the excavation, and also down slopes indicates the embankment. The slope is very steep. The amount of the meter cube of excavation and the embankment is very large. And also the second property is the maximum ordinate of the mass curves occur at the point where excavation ends and the embankment starts. When we see the minimum ordinates, the minimum ordinate means this one. The minimum ordinate will be going to the cutting sections or embankments will be ends and excavation will be started. And also the third part is cutting and fill sections between the points at the points at which any horizontal lines cutting off a loop of the mass curves is exactly balanced. This is a balance line. This line is zero balance line. We balance the cutting sections as well as the filling sections. And the fourth property will be the area below the balance line indicates the hailing of excavation to the embankment from the right to left, and there is the area above the balance line indicators the hails from left to right, and also will be the ordinate at any station represents the accumulated amount of surpluses. So this material is as waste materials. So this waste material does not indicate the amount of cut or fill at any sections. As examples will be computed mass hole diagrams. So the previous video will be calculate the adjusted fills and the adjusted cut volume. So from that will be continue to the aggregated the volumes. So from start from column 8 up to end 9. So for example, we'll have last time discuss about up to 8 and 9. So today's will be this video also deals about this net volume or and also will be the aggregate volume. So this net volume will be get from 9 minus 139. It is 113. It is negative. Negative indicators a fail. 7 minus 299. It is minus 292. It is a negative. So we have also will be in cutting section is positive. So this one is cutting section. So the cutting sections will be 157 minus 132. So we have gets positive 25. So it is a positive value. So we have it is a positive value. So we have gets the aggregated or the cumulative volume. So the first is 0 minus 113. It is negative 113. Negative 113 minus 292. It is minus 422. So minus 422 minus 451. It is minus 873. So we have add. So in cutting section also will be it is a positive. So add the in the cumulative. So the negative value will be decrease. So for example, is when we see 1327 plus 25, it is 1302. It is negative plus 118. It is 1122. So we have like this. So the mass hole diagram is plotted by using this mass hole diagram ordinators, the y-axis, and by using this one is the station is an x-axis. Interpretation of mass hole diagram. So when the mass hole diagrams slope down, it is negative, and preceding section is in filling. So there is upward, it is a positive. The difference in the mass hole diagrams ordinate between two stations will be represents the net accumulative between two stations. For example, the net accumulation is between the at station 6. At station 6, the cumulative will be negative 1302, 1302 at station 12. At station 12 there is 904, so this one is the net cumulative values. In the horizontal lines or the mass or diagram defines the location where the net accumulation between the 2 points is 0, so this one is a balance line. So this one is a balance line. This one is a balance line. So we have flowed. This one is a mass hole diagram. So this one is gets with the cumulative volume fill and as well as the cutting value, and the station will be this one. So each point will be, this one is a point, one loop, second loop. This one is a fill section. This one is a cutting section. So the cutting section will be suitable for the filling section. So we have moved the material with this one. This one is less than 300 up to 500 meters. There is a free hill. This one is above 500, so it is the overhill distance. Balancing the earthwork using the mass hole diagram, the design should be carefully assess the project before starting to the design. So balancing the earthwork by using the first will be adjusting by the alignment, horizontal alignment, vertical alignment, and also the cross section. Earthwork analysis also will be deals assuming the freeheld distance and find by trials horizontal lines to intersect the curves at A and C. So A up to C length is freeheld distance. So as you show in the figures will be, this one is A up to C is freeheld distance. Below this part is from A up to A apostle is overhill distance. And the second examples will be deals about the computing balance pointers stations, how to balance the balance pointers. So the balance pointers will be the changing from the cutting to filling, and also will be vice versa. And the balance point at D will be between station 9 and 10. So between this there is ordinate or the accumulative volumes. At 9 will be, it is negative 299, at 10 is positive 201. So we have calculated the balance point. So the balance point is 9 plus 299 over 291 plus 201 over the distance between station 9 and 10. It will be 100, so times by 100 there is 9 plus 16. So the balance point is at the first loop is 9 plus 16, and the second will be also calculated in these parts. So it is between 17 and 18. So the 17 will be volume will be at the tops is 303, and at it is station is the ordinate value will be 179. So we have calculate at 70 plus 63. The economic analysis also is very important. Economical length helix will be limit of helix is equal to free held distance plus the unit price of the borrow unit price of overheld distance. So free held distance is 1015. So the borrow material will be by meter cube is 8 burrs, Ethiopian burr. So overheld distance will be 5 burr per one station or 100 meters per meter cube will be calculated. So lastly we'll have get economic limit of hills will be 3100 meters. Listed below are a few considerations in determining the best earthwork design. The first is the right of way is restriction may be necessary importing borrow material from the required embankments. Large quantity of inferior or deleterious materials are encountered in the excavation. There is unsuitable material, so as considered as waste material. Special condition for deep cutting. So this deep cutting is a large amount of embankment, so this is reasonably held distances. This saturation, some excavator material will be wasted, and also will we need to carry the road levels considered above the existing grounds through flooding will be generally require borrow excavation. So we have increase the elevations of the embankments, and also computing over hill pavements. So this free hill distance in highway constructions contracts will be 500 feet, and overhill distance will be 11 feet cube per stations. So the mass held distance diagram shown in the figures determines the extra compensations that must be paid to the contractors. So the cutting and filling between the stations 109 plus 16 in the first loops, and the second loops will be 70.63. So this the first will be determine the number of cubes over hill. So this one is between 9 plus 16 up to 1763. There is the free hill distance will be interpolating between the 11 plus 00 and 12 plus 00. So overhill distances ordinate at station 11, it is the volume is 638 plus the difference between the ordinates 12 and 11s 20 over 100. So it is will be 904 minus 638 at 11s times 0.2. So we get the overhill distance is 691. And also we'll have overhill distances between the station plus 16 plus 20. So we have gates also will be 646. So there is a value is not equal. So and also determines overhill distance. So overhill distance between 9 plus 00 to 10 is the volume moves 201. Last time will be calculated, and the free hill distance will be 114. So from 10 up to 11, the volume moves is 638 minus 21 is free, so 437. The distance moved to the free hill distance will be 70 feet. So the averagely will be the distance is 10 feet, and also overhill distance moving between the 9 plus 16 and 11 plus 12. It is at we have get 201 between 6 plus 16 and 10. So we also will have get for 14. So overall hill distances between 17 and plus 63 and 16 plus 20 is 303 feet squares, and the average distance between the free hill distances will be calculated by 16 plus 20 is 70 plus 63 over 2 the distance plus 70 plus 00 minus 16 plus 20, it is 111.5. and also we have from station 17 up to 1620 also will be gates. So lastly the overhill distance will be gates 87.6 plus 72.1, so it is final overhill distance is around 159.7 feet. So this will be times by the cost will be 11, so overhill distance as well as the station. So the cost will be 11,858 birrs overhill cost due to the contractors. Thank you for listening my video.